The Japanese wanted to build an elevator directly to space, stretching 96,000 kilometers. Without building rockets or burning a drop of rocket fuel, they would walk inside, and after 7 days, the door would open, already 36,000 kilometers away. Even crazier, what really stopped it wasn't money, but a rope that humans still couldn't build. It sounds like science fiction, but Japan's Obayashi team really put it into their engineering concept, targeting 2050. The entire system is not a skyscraper piercing the sky, but rather an ultra-long cable stretching from the sea near the equator all the way into space. Beneath it is a floating Earth harbor, which crosses 36,000 kilometers of low Earth orbit and ultimately extends 96,000 kilometers away. The most counterintuitive thing is that it is not supported by a single tower, but uses the Earth's rotation to keep the entire cable taut at all times. You can think of it as swinging a rope. The lower part is pulled by Earth's gravity, and the upper counterweight rotates with the Earth, creating an outward centrifugal effect. As long as both sides reach balance, the cable in the middle stays taut. Darlin Group envisioned a terminal counterweight of 12,500 tons. In other words, humanity is not trying to build a 96,000-kilometer-high building, but rather to tie a rope to the Earth that is twisted straight by its rotation. But the real difficulty starts here. Ordinary steel cables simply can't withstand space, because the longer the cable, the more terrifying the weight it bears underneath. It might break before it reaches thousands of kilometers. So Obayashi Group pinned their hopes in carbon nanotubes. This material is theoretically light and strong, but transforming from millimeter or centimeter materials in the lab into a giant cable stretching tens of thousands of kilometers and requiring stability everywhere is one thing. If there is a serious defect in the middle, the entire passage may fail. Materials are the toughest bone to crack in a space elevator, but they're far from the only one. Assuming the rope can finally be built in the future, the construction method is even counterintuitive. It won't be built section by section from the ground, but will first be sent into space by rocket using the initial seed cable, then unfold from orbit toward Earth and higher upwards, lowering one side and extending outward on one side, allowing the system to gradually reach balance. The most ironic thing is that something that might reduce rocket dependence in the future has to be delivered by rockets for the first step. And this seed cable is just the beginning. According to Darlin's publicly available engineering simulation, the initial cable is about 20 tons. Later, jet extension ropes will be lifted one by one, carrying new reinforcement materials, like adding new fibers to each thin thread. This reinforcement was not 10 times, nor 100 times, but about 510 times, ultimately increasing the main cable mass to about 7,000 tons. Just by keeping this cable thick, it could last about 18 years, and the entire cable construction would take nearly 20 years. It doesn't feel like a bridge built all at once, but more like a tree growing layer by layer in space. Only when the main cable is strong enough will true jet vehicles be qualified to carry both people and cargo. The Darlin Group envisions a single unit with a maximum payload of up to 100 tons. Unlike rockets, it will not break out of the atmosphere in just a few minutes, but instead continue climbing along cables, reaching a low Earth orbit station at 36,000 kilometers in about 7 days, and continue upward. The cables also extend to nearly 96,000 kilometers, with massive counterweights holding the entire system in place. Sitting inside, what you see is the Earth beneath your feet that gradually shrinks from a vast view into a blue sphere suspended in the darkness. But the real engineering problem is not just about materials. The 96,000-kilometer cable must pass through the atmosphere, high-altitude wind fields, and satellite activity areas, while also facing vibrations, tension changes, particle or ballistic radiation, and space debris. If a section of an ordinary bridge failed, the road could be closed for repairs. If this cable had a problem at a critical location, it could affect the entire traffic line between heaven and Earth. So even if one day the elevator doesn't meet the length standard, it doesn't mean the space elevator can start construction the next day. Once these problems are truly solved, its value will go far beyond just sending tourists into space. Satellites, space station components, and even future deep space missions could be repeatedly sent up along this route, rather than having to drag large amounts of propellant from the ground each time. The further you go outside the cable, the higher the velocity at which objects rotate with Earth, and in theory, this place could even become a transit gate to the Moon, Mars, and even farther deep space. At that point, it would no longer be an elevator, but a super orbit directly connecting Earth to the space transport network. Don't forget, how far are humans from this scene? On June 12, 2026, Jingguang University's Star-X satellite successfully entered its designated orbit. It plans to unfurl a 1-kilometer-long rope in space and have the robot move along it. Note, 1 kilometer. The main cable planned by Darlin Group is 96,000 kilometers. Humans are still experimenting with the first kilometer, yet they are already designing a road that spans nearly 100,000 kilometers. This is the most stunning part of the space elevator. So, whether we can really ride this elevator in 2050 is now uncertain. The concept of Obayashi Group still exists, but what truly stands in the way are materials manufacturing, dynamics control, spatial environment maintenance, and decades of engineering capabilities. Perhaps one day in the future, rocket launches will no longer be the most stunning sight of humans entering space. The real shock may be the moment you step into a hatch, press a button, and then climb up until the Earth beneath your feet slowly shrinks into a blue planet suspended in the darkness.